Yes. Hi everyone. I am SS Kiran. I am dealing course is electronic devices and circuits. Okay. In this course, I would like to discuss about problems on Clippers circuits. Okay. Let's start the first problem. Okay. Sketch the output voltage waveform of following circuit. Okay, in the circuit the input waveform is square wave. Okay, the peak to peak voltage 10 volts to minus 10 volts. Here there is a two peaks. One is the positive peak, other one is the negative peak, right? So while there is a two conditions here, I will write one by one. Okay, this can be treated as a note. The positive peak diode starts the conduction. Why? Because this is positive. Okay, this is anode terminal. So positive terminal or positive peak is connected to anode terminal. Diode starts the conduction. So it is a on state. So in ideal case, this can be treated as a short. For example, if it is negative peak diode, so this is negative peak, this negative terminal or negative peak is connected to anode terminal. In this case, diode is a off state, so circuit is open. Okay, so only it is responded positive peak, while applying negative peak there is no current is flowing in this circuit due to open circuit. So in this circuit, this negative portion is terminated, this negative portion is trimmed, this negative portion is removed. So this is called negative clipper. Okay, negative portion is trimmed, negative portion is clipped. So this can be treated as a negative clipper. So if you apply the positive peak, the diode is shorted. The diode is shorted. Then resistor is as usual. The one more resistor is connected series. This is 3 kilo ohms, 3.3 kilo ohms. This is the V out. This is one more resistance, that is the 2 kilo ohms. This is the circuit is converted when applying a positive peak. Okay, now examiner is asked what is the output voltage waveform. So here the input voltage is 10 volts. Okay, while applying the positive peak, the input voltage is 10 volts. So now I would like to find out V out equal to, so particular resistance I would like to find the output voltage. So input voltage, so V out equal to input V input voltage into particular resistance can be treated as a RL, and total resistance, so we can call it as a R1 plus RL. So at final, V out equal to, what is the input voltage? That is 10 volts into what is the particular resistance? That is 3.3 by total resistance 2.2 plus 3.3, both are kilo ohms. Okay, if doing some mathematical calculation, we can get around 6 volts of the output voltage. So the sketch output waveform is very simple. So just you draw some voltage, that is 6 volts. Okay, this negative portion here I have drawn with green color. So negative portion is 0. So this output voltage is 6 volts. Okay, right. We will go with the next problem. Okay, okay. Now determine the peak output voltage for negative shunt clipper as shown in the following circuit diagram. Anyway, the input voltage, the input signal is sinusoidal peak value, okay, peak value 12 volts, sinusoidal peak value. The barrier voltage of silicon is 0.7 volts. In this time, not considered ideal case. Series resistance with 500 ohms, series resistance with 500 ohms, and load resistance is 2.5 kilo ohms. Yes, same procedure. There is note if it is positive peak. If it is positive peak, what happened? So this is positive peak, this is positive, this positive peak, this is the cathode terminal. What happened in this case? Diode is open circuit, okay, positive peak, positive peak. So cathode terminal is connected, this positive is connected to cathode terminal, diode is open circuit. Now what happened? The circuit is converted. The circuit is converted to following circuit diagram. It's very simple. This is input is 12 volts. Input is 12 volts. The output of the circuit diagram. So this is the open circuit. This is the open circuit. We have to write as it is this 2.5 kilo ohms. 2.5 kilo ohms. You have to calculate the output voltage, that is the V out. So what happened? This is the open circuit. Just erase this one. Simply we can calculate the output voltage by helping of the old formula. This is the 500 ohms. Okay, what is the formula? Very simple. Just you can write output voltage. Okay, V output voltage equal to particular resistance. Before particular resistance, total input voltage 12 volts into particular resistance 2.5 kilo ohms by total resistance. Okay, that is 500 ohms plus 2.5 kilo ohms. Okay, if you convert this 500 ohms to nothing but 0.5 kilo ohms. Okay, at final it will get 2.5 plus 0.5, you will get around some 3 kilo ohms. Okay, now if you doing this mathematical calculation, this kilo ohms and kilo ohms get cancelled. At final we can expect 10 volts of the output waveform voltage. For which peak? For applying the positive peak. Once if you apply the negative peak, the diode starts the conduction. The circuit diagram is converted like this. Okay, so here ideal case, that is 0.7 volts. 0.7 volts you can write as it is circuit diagram. Whatever we can give the input voltage, so across the output terminal, that is V out, it is maintaining built-in potential is 0.7 volts. If it is positive peak, that is 10 volts. If it is negative peak, that should be a negative peak, output voltage equal to 0.7 volts. Okay, what is the output waveform? Very simple. I will draw in neat manner. So about the output waveform, I will slightly, okay, right. So output waveform is this is the input waveform. This is the input waveform. So output waveform is, this is how much? This is 10 volts while applying the positive peak. While applying the negative peak, we can get like this. This is the 0.7 volts. This is the while applying the negative peak. Okay. Now next problem. Sketch the output voltage, okay, V out for the circuit as shown in the following figure. Assume both diodes are the ideal case. Yes, very good problem. So first you have to consider the positive peak. Okay, in detail, I will explain one by one. So positive peak means this is the positive supply, this is output, and one the negative. So this positive is connected to this cathode, this positive is connected to anode. So if you apply the positive peak, what happened? There is two diodes, D1 is on, D1 is on. What about D2? What about D2? D2 is off condition. Okay. If you apply the positive peak, D1 is on. So D2 is off condition. So if you apply the positive peak, D2 is off, nothing but this is the open circuit. What happened? This is the open circuit, means there is no current flow here. There is no current flow here. If you apply the positive peak, if you apply the positive peak, V out equal to 0 volts. So what happened? So positive peak is completely clipping. So this circuit is called positive clipper. What happened? This is called positive clipper. What happened? In D2, D2, this positive is connected to cathode terminal. So it is open circuit. The circuit is open. So V output is 0 volts. Right? Now we will apply the negative peak. What happened? Now we will apply the negative peaks. What happened? This is the negative, this is the other one is the positive. So what happened? This negative is connected to anode. So what happened? This D1 is off condition. So ideal case, D2 is on condition, means what happened? Directly it should be short, this should be off. Now I will redraw this circuit diagram in a neat manner. Okay, now this is the circuit diagram. So here D1 is off, no need to write this one, this is the short. So again I will take this resistor. This is the input voltage, that is minus 10 volts, minus 10 volts. Okay, now this is the output of V out, output of the V out resistance is the 5 kilo ohms. This is also input resistance is 5 kilo ohms. Okay, now simply we can write one formula, very well known formula. V out equal to total input voltage minus 10 volts into particular resistance, that should be treated as a 5 kilo ohms by total resistance. Okay, 5 kilo ohms plus here I will write once again 5 kilo ohms plus 5 kilo ohms. Okay, so what happened? Total kilo ohms get cancelled. Okay, 5 plus 5 10. So 10 is cancelled. Around this minus is follow. So minus 5 volts. Okay, then what happened? There is if you draw the output waveform, very simple. This is the positive clipper. So this is, there is no positive peak. Once if you consider the negative peak, that is the minus 5 volts. Okay, this is the minus 5 volts. Okay, okay, keep watching. I will upload more problems regarding of these clippers and clampers. These are called non-linear wave shaping circuits. Okay, thank you so much.